Hello, everyone. Thank you for joining us today in our ISAC newsletter interview. We are focusing this time on geosensing and communications in Wi-Fi networks, and we have with us today one of the researchers pioneering this area, Professor Joerg Widmer, who is at INDEA Networks in Spain. He's an IEEE fellow, a distinguished member of the ACM, and he has published many papers in this area and got many best papers awards as well. Joerg, thank you so much for joining us today and for giving us your perspective on this super interesting topic for many people right now. I will go through.
Thanks a lot for inviting me.
No, it's our pleasure to have you here. I will go to the first question directly. We don't have too much time. These interviews are short. I think you know well that the IEEE 11BF group is a new task group about wireless LAN sensing. And there is a lot of activity right now to redefine the required modification in the MAC and PHY layers to enable enhanced sensing capabilities. Do you think that the technology, the algorithms, and the protocols are ready to meet the industry requirements for these new use cases, or we still need new research?
So it's amazing how far we've come since the first Wi-Fi based location systems like 20 years ago. And what is feasible now, what state-of-the-art research has shown in terms of sensing Wi-Fi signals through walls, activity recognition, health monitoring, and of course localization and simultaneous localization and mapping. The capabilities that have been shown to be feasible with Wi-Fi sensing are impressive. And for most use cases that are relevant to industry, I mean, there are already algorithms that are out there that solve that problem partly. With one big caveat, and I think what's still missing is robustness and practicality. So just as one example, right, breathing rate detection works very well if the person is facing the access point and is standing very still. But doing that in a sort of dynamic environment with the person moving around, it's impossible, right? And same for a lot of other cases, right? Under benign circumstances, in a controlled environment, they work very well. But for many industry settings, we need something way more robust. And I think that's really where we need more research to make sure that these don't just work in like little toy scenarios in the lab, but really in the real world where users will use these devices and where industry will use them is very uncontrolled, and they have to be robust enough to function in whatever environment you throw at them.
Oh, and what about localization accuracy? Because they seem to target very accurate localizations in the order of 1 centimeter for indoor applications, 10 centimeters outdoor, which I think is hard.
Absolutely agree. And then the question is also, what are the cases where you need such an accuracy, but you cannot afford a dedicated sensor, right? Because if you really have sort of an industry environment and you need reliability and accuracy, right? Okay, take a radar sensor, or take a LiDAR device, or any other kind of sort of well-known sensors that are robust and that function well. On the other hand, we've seen that such accuracies are achievable, right? So with high enough frequencies, with wide enough bandwidth, you can achieve this. And the big question is sort of, again, what's the environment where you want to use this, right? Because obviously then if you have non-line of sight, or you have a very rich multipath channel, you have a complicated mobile environment, right? It will be very hard to achieve these accuracies. Yeah,
I think so too. I think it's still a challenge to go really to very precise localizations. And talking about localization, we have different possibilities there in terms of the approaches, the nature of the approaches. There are a lot of works that try to develop a radar-like approach where they exploit reflections on the objects to be localized, or other approaches just exploit the direct receive signal. And what do you think is going to give us better solutions in terms of accuracy and robustness?
So clearly the easiest approach is sort of directly sensing a signal from another wireless device, right? Take the line of sight path, either do angle-based localization or measure time of flight, right? And this is something that works already very accurately and very robust in a very robust way, right? And consumer devices already integrate something like this, where with this FTM from 802.11, which was standardized, you can achieve at the moment meter level accuracy, and clearly that's going to improve as devices improve. So that is something that already solves a lot of problems and is very simple and practical and robust. Now, from a research perspective, of course, it's much more interesting to look at the harder problems, right? To really decompose the multipath environment, look at the whole multipath, not just the line of sight path, which obviously at sub 6 gigahertz is very challenging. You have a very rich multipath environment, so you need good algorithms that can decompose that, right? I think there are still significant research challenges to achieve that, again, in a robust way in whatever environment you throw at it. Yeah. And now you asked about sort of radar-like operations, or like, so here basically, I think one thing that's very appealing are these bistatic approaches, where basically you take a normal network as it is deployed, no extra capabilities, and you just observe the CSI that you see from a communication link. Because the nice thing is that you get for free, right? So whatever application you want to put on top of it, well, it already gives you useful information that you don't have to deploy infrastructure for, which is very appealing. And at the same time, of course, it makes it very hard because you have a line of sight path that's used for communication, and then you're trying to sense these weak multipath components to observe what's going on in the environment. And of course, that's much more challenging than if you have a radar-like approach, where sort of the strong signal is the reflected signal that's being thrown back to you. And that, of course, works much more robustly and in many different environments. But it requires full duplex operation, which, of course, normal transceivers that you use for communication, you don't have that. Yeah, I totally agree. And also, you lose some strength in the reflection. So from a signal to noise ratio perspective, it's also challenging. Okay. So yeah, I think we are going to have fun with both approaches, and we still need to develop many new ideas there in both approaches. Yeah, one thing that I think is interesting, again, directly related to the multi-band approach you mentioned before. Directly related to the accuracy we discussed before, and the robustness in different environments. Combining measurements from different devices and from different bands, I think that's one of the things that are really going to help make this more practical. Like, for example, the previous example, right, where one access point might not observe a certain object because it's obstructed or the multipath environment is too complicated. But then if you have many access points and confused information, that might help a lot in making sensing robust and making sure that sort of in most scenarios where you have critical applications that require certain accuracy, things work well enough. Yeah, and I'm talking about fusing information. I think another trend is considering the information that you can get from sensors and also the CSI-based localization, and see, okay, what can I do with both things? How can I fuse these to really increase robustness? What do you think about this new idea of, well, not new, but I think there are more works now about fusing sensors and the radio signal, the information from the radio signal? Mm-hmm. Yeah, I mean, individually, it's already challenging, right? There's still a lot of research going on how to deal with information from bespoke sensors or how to do CSI sensing reliably. So now combining the two, obviously, there's still lots of very interesting research questions to be solved. I think the interesting question here from a practicality perspective is, again, when do you need it, right? Because if you don't need a dedicated sensor, you can make do with CSI alone. Of course, it's much nicer because you don't have infrastructure that you need to deploy. Or if it's really safety critical, often you need a bespoke sensor, because only that is going to give you the accuracy and the robustness that you need, right? So for autonomous vehicles, right, collision detection, you certainly want a radar and not just the Wi-Fi sensing device, which you of course, it's nice to get the information for free, but when safety criticalness is important, right, then you want a dedicated sensor. So here the question is, what are the cases where a sensor alone is not enough? And at the same time, CSI-based sensing is not enough, and you really need to combine the two. And that's an interesting open question, I think. What are the application scenarios where neither one of the two is sufficient?
Well, we cannot forget about reconfigurable intelligent surfaces. Is emerging there in the communication, more in the communication part, as a way to overcome blockage and to improve the network operation. But I think my humble opinion is that it's going to be a key technology for localization more than for communication. I think the improvement in position accuracy that you can get if you have an additional path that is also strong. I'm not talking about using them instead of the line of sight path. I think for localization, you have to use them together, both paths, the paths coming from the RIS and the line of sight path. And there, what's your opinion? What do you think is gonna be like a game changer in terms of the accuracy?
So I think that's gonna, my personal opinion is that's gonna take a while, because from a research perspective, they're extremely interesting, right? So now you can control your multipath environment rather than just being exposed to it, and you have to deal with what you've got, right? So obviously you can turn a bad multipath environment into a good one if you've got enough reconfigurable surfaces that allow to shape that environment. But at the same time, of course, there's a clear cost perspective, right? You have to install those, you have to configure those, and access points are not necessarily expensive, right? Of course, if you think 6G base station, that's very expensive, or 5G base station. But if you think about a tiny Wi-Fi chip, right, that costs a few dollars at most, right? So then if you manufacture those at volume, then it's much more a question of what's the integration, what's the packaging, how do you want to market and sell this, that determines the cost of such device, right? And then sort of having an active relay or another access point doesn't have to be very expensive. So then the question is really, in which scenarios does a RIS either provide you a cost improvement, or is more appealing, more interesting in terms of the sensing it allows you to do, right? And I think it's a whole range of solutions, from like a normal active relay to amplify and forward relay to a reconfigurable surface to passive surfaces that you cannot reconfigure, right? And I think here the RIS are a little bit in the middle, whereas sort of the passive ones, okay, they're clearly cheap. They don't need electricity. They have no active components, right? If it's a sort of a meta material, some paint you can put on the wall, right? That's very cheap. Now, clearly the other direction is, if you need density, okay, deploy another access point. That's very well understood. The cost is very clear. How to do that is very clear. And then where is the niche or the scenario for the RIS in between? I think that's still open. Whereas
that's
from
the
a
open
research perspective, it's very interesting. And I guess we'll have to see what the scenarios are when we need this.
Yeah, and also having simple solutions for the configurations, because the complexity of the mathematical problem of configuring everything at the same time, the transmitter, the receiver, plus the RIS, is not simple.
Exactly. It has to be as easy as plug and play from a deployment perspective as deploying another access point would be.
Exactly.
Yeah.
Okay, thank you. Thank you for giving us all your thoughts about these topics related to Wi-Fi and joint sensing and communication. And I hope people enjoying this interview as much as we did just discussing about the things we're working on. Thank you.
It was a pleasure. Thanks a lot for having me.
Thank you. Bye.
Bye.